We've been asked to solve the triangle where alpha is equal to 64 degrees, gamma is equal to 82 degrees, and little c is equal to 14 centimeters. When I look at the law of sines, I realize I've been given angle, angle, side. And you could also rightfully call that side, angle, angle, because I know a side and two angles is just not the side between the two. But just like we said in the last video, anytime I know two angles, I get the third one for free. So kind of like right away, we're going to be able to think about this as a angle, side, angle. But I know what, I'm just going to go on and draw a picture anyway. I'm going to use this triangle as a guide, though any triangle would work as long as we make sure that A alpha and A are across from each other, B beta and B are all lined up, and C gamma and little c. I've known students and people to do every single problem now just drawing an equilateral triangle and labeling the sides correctly. That drawing is of course not to scale, but that's not going to hurt your solution at all, and it's a nice reference. It is always a good idea to draw a diagram whenever you're solving a triangle, just to make sure we're getting the right angles across from the right sides. So there I have side A and angle, vertex A and angle alpha. That was super easy for me to say. Put vertex C down here, which means this will be my 14 centimeter side, and I'm not worrying too much about doing this to scale here. And then I have B, that would be beta, and then I know that gamma is 82 degrees. All right, so this picture is terribly to scale. I'm going to try to just make it a little bit better by making that a much steeper angle. And there's my 82 degree angle. Let's go on and find beta. It's always a good problem solving strategy to try to find the easiest missing piece of information first anyway. And so let's see. That triangle has to have a total of 180 degrees. Let's take away 64 and let's take away 82, leaving a 34 degree angle at the top. So angle beta here at the top I now know is 34 degrees, and that just lets me focus on finding side A and side B. And so I'll use the law of sines again, and again thinking about missing sides on top because that's what I'm missing. So I have A divided by the sine of 64 degrees, which would then be equal to, and let's see, this is the pairing I'll have to use because I know both the side and the angle across from it. So to find A, I'd need to multiply both sides by the sine of 64 degrees. So let's see, I have 14 divided by the sine of 82 times the sine of 64 degrees. And I find out the little a is about 12.7, always wanting to use units, those are centimeters. All right, now I need to find side B. So I have B over the sine of 34 degrees is equal to, and again, I'll just use what I was given, 14 over the sine of 82 degrees. Went back up there and put on that degree symbol. Always should use a degree symbol when I'm talking about an angle measured in degrees. All right, so I have that 14 over the sine of 82 degrees, close that parenthesis, times the sine of 34 degrees. And this time I get a side of 7.9 centimeters. And now we have solved a side angle angle, which very secretly turns into an angle side angle every time. And again, in the angle side angles and the side angle angles, we are guaranteed one solution. We'll always be able to solve one of these triangles when we have two angles in one side. And that's it for now.